Hello, my name is Taylor, and I will be reviewing two studies that examine how three specific emotions, anger, fear, and disgust, shape memory performance. Together, these studies show that emotion doesn't just influence how strongly we remember something, but how we process it in the first place. The first article I'll be discussing is Capaciu's article titled Recognition Memory for Specific Emotion Words, Anger, Fear, and Disgust. This study begins with the well-known finding that emotional material is often remembered better than neutral information, especially when it's negative or highly arousing. But emotions that feel similar, such as anger, fear, and disgust, don't always affect memory the same way. These emotions share negativity and arousal, but they differ in meaning. Anger is approach-oriented and certain, fear is avoidant and uncertain, and disgust is also avoidant, but with high certainty about what should be rejected. The researchers wanted to know whether these differences in motivation and certainty would translate into measurable differences in recognition memory for emotion-related words. The study consisted of two online experiments in which adults between the ages of 18 and 35 studied lists of words related to anger, fear, disgust, and neutral topics. After a short delay, they saw a mix of old and new words and rated how confident they were on a 6-point scale that each word had appeared before. Using those confidence ratings, the researchers created ROC curves, also known as receiver operating characteristic graphs. These allowed them to separate memory accuracy from response bias. The accuracy measure was referred to as DA, which reflects how well participants distinguished old from new words. The bias measure, or CA, captures how liberally they labeled something as familiar. The approach matters because emotion can make people feel familiarity even when actual memory isn't there. In the ROC curves on this side, all three emotion conditions, anger, fear, and disgust, shift upward and to the right compared to the neutral words. We can see that curve right here, for example. The pattern indicates a more liberal response type, indicating that participants were likely to say old to emotion words even when they were new. But when we look at the accuracies on the graph on the left, the difference between emotions become clear. To simplify the results, accuracy or DA on this side was lowest for anger. It was roughly equal to neutral for fear, and it was at its highest for disgust, especially when all emotions were tested within the same participants. Across the board, the CA values on this side of the graph dropped for every emotional word, showing a general liberal bias in responding. So emotion words increased the tendency to say old, but only discuss actually improved recognition accuracy. These results challenge the simple idea that emotion automatically strengthens memory. Even though anger, fear, and disgust are all negative and arousing, they produce very different outcomes. Anger seemed to impair accuracy, likely because it encouraged quick heuristic judgments rather than deeper encoding. Fear produced accuracy similar to neutral words, suggesting that its uncertainty-related processing doesn't boost recognition. And disgust improved accuracy, probably because it triggered more detailed adaptive processing that fits its role in avoiding contamination or danger. Across the three emotions, people were more willing to claim that they recognized a word simply because it felt emotionally familiar. Together, the study shows that it's not just emotional intensity that matters, but the meaning and cognitive direction behind of the emotion. The second article, published by Regal and others, is titled Emotion Schema Effects on Associative Memory Differ Across Emotion Categories at the Behavioral, Physiological, and Neural Level. Whereas the first study focused on recognizing individual emotional words, this one examined associative memory, specifically how we remember links between emotional cues. The author introduced the idea of emotion schemas, which were mental templates that connected elements of emotion, such as how a fearful face fits with fearful words or situations. They asked whether memory improves when those cues are emotionally congruent, for example, when the face and the word share the same emotion, and whether this congruency effect looks different for disgust compared to fear. To explore this question, female participants studied face-word pairings showing disgusted, fearful, or neutral expressions. Some pairs were congruent, meaning a disgusted face was paired with a disgusted word, while others were incongruent, such as a fearful face paired with a disgusted word. The researchers collected several forms of data. This included behavioral accuracy and reaction time, eye tracking data to see where participants looked, pupil dilation to as a measure of arousal and effort, and in the second experiment, fMRI scans of brain activity while participants encoded the pairs was also collected as well. After each study phase, participants were then tested on which emotion had been paired with each word. Basically, the participants remembered congruent pairs more accurately and responded faster than incongruent ones. But within the congruent conditions, the emotions differed. We can see that over here. Disgust congruent pairs showed the strongest memory, while fear congruent pairs performed even below neutral in some cases. The bar graph illustrates how disgust congruent pairs stand out clearly above the others. Physiological data supported this pattern as well. Larger pupil data predicted better memory for disgust congruent pairs, showing deeper engagement. Eye tracking also revealed that patients shifted their gaze back and forth between the face and the word more often for disgust pairs, meaning that they were actively integrating the two cues. For face pairs, however, it prompted longer fixations on the faces alone, reflecting a narrower perceptual focus. At the neural level, fMRI results showed increases in activation in the left inferior frontal gyrus during successful encoding of disgust congruent pairs, which was an area involved in semantic and linguistic integration. In contrast to this, however, fear congruent pairs activated the right fusiform gyrus, which specializes in visual face processing. The study demonstrates that emotion schemas guide how we form associations in memory. When the emotional cues match, the brain can bind them together more easily, but the strength of that effect depends on the specific emotion. Disgust appears to activate semantic networks, prompting deeper, meaningful based processing and stronger associative links. Fear, in contrast, focuses attention on visual features, which helps with vigilance but not with building associations. In other words, disgust encourages elaboration and integration, while fear encourages perceptual monitoring. The difference helps explain why disgust improved memory in both studies, while fear showed little consistent benefit. When we compare the two studies, a consistent pattern emerges across them. Anger, we can see here, reduced accuracy and increased bias, suggesting that participants relied on fast heuristic judgments. Fear maintained attention on perceptual details without enhancing recall for meaning. And disgust produced the clearest benefit, showing stronger recognition for individual words and stronger associative memory for emotional pairs. Each emotion seemed to engage a different cognitive route as well. We see that anger drives heuristic processing, fear relies on perceptual focus, and disgust activates semantic integration. Together, the findings reveal that emotion doesn't simply intensify memory, rather, it shapes how the brain remembers. These are my references. Thank you.